In this video, we are going to talk about factoring by grouping. These notes can be found on page 2 of the reference sheet that I posted on Google Classroom or on page 3 in the note packet that I passed out in class. All right, so method 2, factoring by grouping. This method only works for polynomials that have 4 terms. Okay, and we're actually going to use a GCF, which is something that we focused on in the last lesson. So just to refresh your memory, we're going to use the GCF to factor in number 1 and number 2. If you would like to pause the video and try these on your own, since we've talked about them before, feel free to do that and press play when you're ready to check your answer. All right, so our GCF in number 1 would be x plus 5. If we look at the terms to the left and the right of that minus sign, both terms have x plus 5. So if we have a GCF, we're going to divide by that GCF. We also know that the GCF goes out front. And then in parentheses, after the GCF, we write down what would be left after dividing by that GCF. So as you can see, the x plus 5 cancels when we divide. And all that we would have left are the coefficients that were in front of the parentheses. So the 4 and negative 3y. Those two terms make up our second factor. So this would be our answer for number 1. Number 2, we're looking for a GCF between the two terms on either side of that plus sign, and both terms have an x minus 3. So our GCF is x minus 3, which really means we're taking out x minus 3 or dividing by x minus 3. Write down the GCF. And if we cancel out the GCF, we have an x plus 5 left over. So that x plus 5 makes up our second factor. Anytime you want to check your answer, remember factoring is the opposite of distributing. So if you want to check your answer, go ahead and distribute. When you multiply these two expressions together, you would end up back at the original question. All right, so number 1, the steps are listed there to the right. So if you need to refer back to these when you're doing the practice, they're kind of a nice way to organize your work. So as you can see, the first step is to look for a GCF greater than 1 for all 4 terms. So if we look at number 1, 6x squared plus 15x plus 8x plus 20, all 4 terms do not have a common factor bigger than 1. Okay, they don't all have x, and 6, 15, 8, and 20 do not have a common factor together. So moving on to step 2, we're going to group the first 2 terms together and the last 2 terms with parentheses. You can use parentheses or brackets, whatever works for you. Step 3, we're going to look for a GCF only in the groups. So we're only going to focus on the first 2 terms, 6x squared plus 15x. These 2 terms have a GCF of 3x. So I'm going to factor a 3x out of those 2 terms. So I would have a 2x plus 5 left over. Now we're going to move on to the second 2 terms. We have 8x plus 20. Now look for a GCF only within those 2 terms. So they both don't have x, but they do both have a factor of 4. So I'm going to factor out a positive 4, which would leave me with 2x plus 5. Now notice this looks really similar to questions 1 and 2. Both of these have a factor of 2x plus 5. So what I'm going to do next is factor out the 2x plus 5. And if we factored that out, it would cancel out the 2x plus 5 in each, and all we would be left with is the 3x plus 4 from out front. So our 2 factors for this example are 2x plus 5 and 3x plus 4. If we multiplied these together and distributed, we would end up back at that original 4-term polynomial. So in number 2, first step, we're going to check for an overall GCF. So look at all 4 terms. In this case, they don't have anything in common. So we're going to move on to the next step, which is grouping the first 2 terms and the second 2 terms. If we focus on the first 2 terms, 5x squared minus 15x, both terms have a factor of 5x. If I factor out a 5x, I'm dividing by 5x, which leaves us with x minus 3. In the second 2 terms, 2x minus 6 have a common factor of 2. So if I take out a 2, I'm left with x minus 3. Take a look. Both terms have a factor of x minus 3. So I'm going to factor that out as a GCF. If I factor out the x minus 3, it's really like we're canceling x minus 3 in both factors. And if it cancels in the first one, we still have the 5x from out front. And if it cancels in the second one, we still have a positive 2. As always, if you want to check your answer, you can just distribute and multiply just to make sure that you did it the right way. If you multiply, you should end up back at the question. All right, number 3, check for an overall GCF. There is not an overall GCF in this one, so I'm going to group the first 2 terms together and look for a GCF between 15x squared and negative 18x. In this case, we can factor out a positive 3x. Now, if we look at the second 2, we got a negative 5x and a positive 6. So I know my purple kind of covered up the negative there, but it is important to recognize that this is a negative 5x. We want this to match up with what's in parentheses in the first expression. So we have a positive 5x minus 6 in this parentheses. So what we can do here is factor out a negative 1, which would flip both of those signs. So now this becomes a positive 5x minus 6. And we can factor out that 5x minus 6 as our GCF. If we factor it out, we would still have the 3x minus 1 when we cancel 5x minus 6. Okay, question number 4. We're looking at all 4 terms first to see if they have an overall GCF. In this case, they do all have a factor of 3. So I'm going to factor out 3 first. And remember, you still want to include this out front. It doesn't just disappear. So we still have a factor of 3. We're just writing it as the GCF out front. So this would give us x squared plus 2x minus 6x minus 12. And now we are going to factor by grouping. So the first 2 terms have a common factor of x. Group the second 2 terms. They both have a common factor of 6, and I'm going to factor out a negative 6 because we want it to end up as a positive x plus 2 inside the parentheses. Okay, so now our x plus 2 is a common factor. And if we factor that out, we would have an x minus 6. Don't forget about your GCF from the beginning, so we'll just write the 3 out front. Okay, next question, look for an overall GCF first. So if we look 30, 12, 75, and 30, all have a common factor of 3. So I'm going to take out the 3 as our GCF. They also all have n. So pick the one with the smaller exponent. We're going to factor out an n squared as well. Okay, at this point, we can continue to factor by grouping. So if I group the first two terms together, these have a common factor of 2n. Group the second two terms together, we have a common factor of -5. And I am factoring out the negative with it so that I get the same signs as the 5m minus 2 in parentheses before. So then our 5m minus 2 is our GCF for this next step. So I'm going to factor out 5m minus 2. Okay, if we factor that out, it cancels in both terms. So we still have a 2n minus 5 as our second factor. And we have that GCF from earlier, the 3n squared. This question is an interesting case. So if we look at number 6, first check for an overall GCF, and there isn't one. So 3, 8, 6, and 4 don't have a common factor. A is not in all of the terms, B isn't in all of the terms, and X is not in all terms. So what we could try next is to group the first two and group the second two. Because we have 4 terms, we might as well try factoring by grouping. But now if we look at the first 2 terms, they still don't have anything in common. And if we look at the second 2 terms, we can factor out a 2, but then we're kind of stuck because it doesn't match anything with the first 2 terms. So what we can actually do is try to rearrange this and see if maybe we can combine 2 terms together that would have a GCF that we could factor out. So one thing I'm going to do is switch the order, and I'm just going to start by moving the 2 middle terms. So let's flip, using the commutative property, we can flip the 2 terms in the middle. Okay, so if we try grouping this time, the first 2 terms do have a common factor. We can factor out a 3 and an x. If we factor out 3x inside the parentheses, I would have a minus 2b. Okay, in the next term, we could factor out a common factor of 4. Now, if you notice, these two aren't quite in the same order as what we have in the parentheses before, the a minus 2b. So one option is you could actually flip these as well. So if you wanted to make sure that the term with a comes first, let's just make this a minus 4a. Plus 8b. So we're still using the commutative property, we're just flipping the order. And now we can see it's probably a better idea to factor out a -4, because this would allow us to get a positive a and a negative 2b, just like the parentheses in the first expression. So now we have a common factor in both, and we can factor out this GCF. When we factor out the GCF, we would have a 3x minus 4 in the second factor. So this would be your answer to this one. The next examples you can try are the you try questions on the next page of your reference sheet, and I will have a video you can watch to check your answers for that.